Alright, let's start off with the vocabulary. You have continental drift, which is the idea that continents slowly move around Earth. And they move around the Earth on average about 5 centimeters per year. And it doesn't seem like that's very significant, but when you look at how old the Earth is, it's about 4.6 billion years old. 5 centimeters per year, that's a long distance, right? 4.6 billion times 5 centimeters. Well, it's not quite 4.6 billion because the continents didn't exist when the Earth was first formed. Continents didn't start showing up until about 2.5 billion years ago. And then the other vocabulary term is supercontinent, a landmass made up of all the continents. All right, and we've had 3 of them. The most recent one was Pangaea. You guys have heard it pronounced Pangea. It's more properly pronounced Pangaea. It's a Latin word. And before that we had Rodinia, and the very first one before that was Pannotia. Most people have only heard of Pangaea. A lot of people have heard of Rodinia, but those people have studied earth science, generally in college. And then Pannotia is only talked about by very few people, even within earth science, because there's so little evidence of it because of how often the land is changed. And so there's very little evidence left of it. So it's not talked about that much, but there's plenty of evidence to support the fact that Rodinia existed and Pangaea as well. For our notes today, and you got to make sure that you write these down in your textbook properly, exactly the way they're written here. You have to have the bullet points, indent A, number 1, indent B, blah blah blah, 2, 3, and so on, just like an outline. Alright, so here we go. Seafloor spreading is the driving force of continental drift. That you already know, but I gotta make sure you put it in your notes. Alfred Wegener proposed the idea of continental drift, and yes, it's Alfred Wegener, not Wegener. You'll hear some people on some videos that I have posted for you call him Wegener, because there's a W here, but he's German, and in German there's no W sound. The W makes a V sound in German. His name is Alfred Wegener. Okay, Alfred Wegener proposed the idea of continental drift. His 5 main points of evidence for continental drift were that the continents fit together like puzzle pieces, which I'll show you in a minute. Where it seems the continents fit together, there are matching mountain ranges, matching fossils, okay? So then there's climatic evidence, and climatic evidence includes coal deposits and glacial deposits, glacial scratches. Now how coal deposits are climatic evidence is that there are coal deposits found in areas near the poles and areas that are very cold on Earth, and they couldn't have been formed there because coal is only formed in subtropic and tropic areas, which means they had to have been formed while they were closer to the equator. Glacial deposits and glacial scratches are evidence that glaciers existed in parts of the world that you don't see any glaciers because it's too hot. Okay, but these continents used to be further away from the equator at one point, and the glaciers were able to appear and grow. And as they grow, they're moving along. Glaciers are moving along, and they're scratching up the rocks below it, leaving scratches. And the scratches all go the same direction. They go the direction of the flow of the glacier. And when you line the continents together, when you connect them together the way it looks like they fit together, based with all the other evidence like matching fossils and the mountain ranges that line up together, the scratches all point towards the center of where the glacier originated from, which is absolute proof that the continents were once together in that way. Okay? Alright, so now let's take a look at some of these evidences. All right, so the continents, they look like they fit together like pieces of puzzle. And one thing you need to know is that it's not that it's not the coastline of the continents that match up like pieces of puzzle, although that too looks like it does. Because often the continental shelf is that parallels the coastline, but not always. And what is a better matchup isn't the coastline, but the continental shelf. The continent does not start on the coastline. The continent starts off the coastline on the continental shelf in the ocean. Okay? And so these are puzzle pieces that you're going to be using tomorrow in class for our little activity in putting together Pangaea. All right? But let's take a look at an actual map of the Earth. Real quick, let's see here. I thought I had one ready. Well, we'll take a look at this. So you can see here that we have North America, South America, Africa, Antarctica, India, Australia, and right here, South America fits in right in here in Africa. This northwest coast of Africa fits in with the northeast or the east coast of North America. All right, and also up here, Greenland fits in real well with North America and connecting up here with Northern Europe. Okay, same connections over here. They're less obvious because these are more kind of shapes that are not as distinct. The shapes here are very distinct though. And part of it has to do with the youth of the Atlantic Ocean. The Atlantic Ocean is spreading. And it's a relatively new ocean, and it's getting bigger and bigger. So these coastlines have had less time. These edges of the continents have had less time to erode, weather and erode away than the other continents have, and the other sides of the continents. So they look very much alike with each other. It's easy to see that they were once connected. So let's combine that. Let's combine that with some of the evidences that go along with how they connect. So let's take a look at these fossils. All right, you have fossils of animals and plants that cannot travel across the ocean, but they're found on these different continents that today are thousands of miles apart. The Mesosaurus is a freshwater dinosaur. It cannot swim across the ocean. It's salty. It would die. Okay? This Synognathus, another walking animal, cannot swim across the ocean, lives on land, and yet it's found in South America and Africa. Same thing with the Lystrosaurus. The Lystrosaurus is found on several continents that are all separated by an ocean. Okay? And then there's this plant. It's from a fern, and it's found even in Antarctica. Well, ferns can't grow in Antarctica. It's too cold. Well, Antarctica didn't used to be by the southern pole. It used to be closer to the equator. And it's found in all these different continents. Now, today, when you think about the continents, you think about very specific types of animals and plants that live on those continents that don't live in any other continents. As an example, in Australia, they have kangaroos and koalas. You're not going to find kangaroos or koalas anywhere else. Okay? They cannot swim across the ocean. And pigs, originally from Asia, or the whole Eurasian continent rather, eventually were not originally in North America, but they are today because they've been brought over by farmers on boats. All right, and so now there are pigs here. There's plants that are here that are not in other parts of the world. Okay, in other parts of the world, like the redwood trees, the sequoia is only found in North America. Okay, it used to be found in other parts of the world because the continents used to be together. In fact, there were sequoias in Russia, and in Russia, it's too cold now, so they couldn't exist. They went extinct in Russia because the continent moved north towards the North Pole and became a tundra. Okay, but here it's still nice, the perfect climate for the sequoia trees, so it's able to survive. Okay? All of that has everything to do with continental drift. All right? Today, we have monkeys in South America and we have monkeys in Africa. But they're different. South American monkeys, also known as New World monkeys, have prehensile tails. That means they're able to use their tails to climb with. They can hang from their tails. They can hold things with their tails. In Africa, the monkeys cannot. Also called Old World monkeys. Because they were once living in both of them here freely, and once South America and Africa split apart, and South America and Africa changed their climates due to the movement of the continents, the different animals evolved differently. The different plants evolved differently, and they had to adjust to their new environments. And so they evolved to have prehensile tails, whereas in Africa they did not. Okay? And you don't see any of them going back and forth between continents today because there's an ocean there. Alright? So all these animals that show up, all the fossils of these animals that show up in all the different continents, if the continents were apart, that shouldn't happen. It doesn't happen today, unless humans brought one animal to one place or another. And it wouldn't have happened then. So the continents clearly were together. And the way the continents match up, like the puzzle pieces, and connect where the fossils are found, works out perfectly. Let's look at another example, or another piece of evidence. Glaciers. This is a map of the world today. Again, you can see how these continents used to fit together here. They've just been split apart at the mid-ocean ridge. It goes right in the middle of this. Okay. But when you put them together, the way it looks like they fit together like a puzzle piece, the glacier evidence comes together, and the scratches left behind start to point towards the center where the glacier originated from. Okay? Again, more evidence. Let's take a look at where coal beds are found, which I mentioned in the notes earlier. There's a lot of coal on the east coast of the United States, right here, and throughout Europe. Okay? Coal is formed in swampland areas. No swamps over here in Europe. Okay? This is all desert right here in this part of Eurasia, and Europe doesn't have any tropical areas. The northeast coast of the United States and Canada, it's too cold. Why are there coal beds here? Why are there coal beds in Russia? It's cold as well. Well, when you connect them together the way it looks like they fit together like puzzle pieces, this is one large coal bed formed all together. That was all one large swampland area, and it was closer to the equator. This is the equator right here. Okay? All right. So tomorrow, we'll be doing an activity connecting the continents together the way they look like they fit together based on the shape, and also based on the evidences found on each of the continents, so you can see firsthand for yourselves how this works. All right?